topics. So today I'm going to speak about a lifelong misconception that every biomedical engineer encounters in their career life, once in their career life. That is like the least problem that will happen. So a lot of people think that biomedical engineering is basically electrical or electronics engineering, ECE, plus a little bit of biology. And that's not true. And the other people think that we are doctors with a little bit of technology knowledge. That's also not true. And other engineering disciplines think that we are a jack of all trade and masters of none. And that's also not true. It's very difficult to explain what is it to be a biomedical engineer. A lot of people think that basically we are a compilation of all the classical engineering disciplines, and we're just there connecting the dots and becoming a bridge. Well, actually, a segment of our discipline is actually connecting the dots and becoming a bridge between medicine, healthcare delivery system, and as well as the classical engineering like electrical engineering and mechanical engineering, manufacturing engineering, etc., etc. However, sorry for the voice. However, we have to take note that into perspective that as a biomedical engineer there are certain traditional technical skills that they have to be well prepared before entering the industry, and I will specify them. And if you're a biomedical engineer and you're graduating year, please take note and self-evaluate how you rank within these technical skills. So number one technical skill will be statics, mechanics, and dynamics. So basically mechanics. How well prepared are you? You should be around the 90% rank. The other one is conservation principles. How well prepared? You should be around 87-ish. And there is structure and properties of materials, strength of materials. Think about its biocompatibility and, for example, bionic eyes, for tissue engineering, and all of the, for example, the yield strength and when the tear and wear of certain stem cells. These things cannot be taught in mechanical engineering, cannot be taught in industrial or electrical and electronics engineering. It is specifically for biomedical engineers to cater and know about it. However, the principles of it does come from science, and you have to know the strength of materials fully heartedly. So we will vote about 85% and above. The other one is momentum, heat, and mass transfer. Of course, if you are dealing with biomedical instrumentations that are in hospitals, you have to be very, very well prepared in tackling heat and mass transfer between a body and a machine. So if it's a class 3 device, you really have to be able that there will not be electrocution, especially with the ground not being set. So you have to be around 80 plus well preparedness in this rank. The other one is biomedical sensors and instrumentation. Biomedical sensors has direct effect on the body. So if you are somebody who did not understand the electrical and electronics principles, you might end up electrocuting the body instantly, and that's not helping at any way any medical doctor. So you have to be very well prepared in how to design biomedical sensors that are going to be an accessory, an external widget for the main instrumentation that could be tackled by robotics or a pure computer software, which is based on a hardware. The other one is, and we're going to give a number of 80% or above. You have to have 80% above in this criteria, or else just avoid becoming a clinical engineer. You might end up killing people in that manner. The other technical skill will be analysis, modeling, control of linear systems. You have to be able to understand and model multiple algorithms in order to tackle basic medical software systems, and also the database with all the EHRs, EMRs, and also the unstructured data that comes from psychological facility. If you cannot actually make a model out of the data that comes out, then you might end up giving or modeling something entirely different and wrong, and you will end up giving the doctors the wrong information and therefore a very poor decision making. So if you are very good at algorithm design and coding, programming, software systems, go for this one. If you're not, then just shift into more hardware based. I hope this was helpful. Thank you.